Module 2, Lecture B, Variables and Input. By the end of this lecture, you will be able to create and assign variables using clear and descriptive names, use the input function to read user input and store it in variables, and combine variables and print to display formatted messages to the user. Understanding Python variables, meaning of variables. When you begin programming, one of the first ideas you learn is variables. A variable is like a labeled container in your program's memory that holds a value, such as a number or a piece of text. This label lets you easily find, use, change, and display that value later. Without variables, keeping track of values would be difficult and error-prone, even for simple tasks. Variables are important because they let programs work with changing or unknown data instead of fixed values. For example, a budgeting tool can store a user's income and expenses in variables, so the same code adapts to different people. The same idea applies in many areas, such as tracking temperature in simulations or player statistics in games. In short, variables act as flexible placeholders that allow programs to respond to new data and changing conditions. Variables do more than store data. They control how a program behaves. Whenever a program calculates results, makes decisions, or shows messages, it relies on values kept in variables. For example, a booking system can use variables to track available seats, check-in status, and pricing, and then decide what options to present to users. As the program runs, these values change in response to new inputs or user actions, so the program can adapt to current conditions. Thinking of variables as flexible, named pieces of data helps you design programs that respond to real-world situations. Python code. Meaning of variables. Variables are used to store information that can change over time. You can think of them like labeled containers that each hold a value for a simple situation. By printing out the values stored in these containers at different moments, you can clearly see how the information they hold is updated and changed during a program. The line with the exclamation mark and the install command is simply a placeholder to install any libraries the script might need. Developers often put this at the top of a script to make sure all dependencies are available. In this case, it is commented out, which means no extra libraries are needed right now, or they are already installed. It mainly serves as a reminder for future changes if the script later requires external packages. We create a variable to store a person's name, in this case, Alex Johnson, so we can easily use or change that name later in the program. This variable serves as a placeholder that holds the text value of the name. By assigning this text to the variable, we can include it in different operations or outputs. This demonstrates how variables store and manage data in a flexible way. We define a variable to store the monthly rent amount of $1,200. This variable stands for the cost of rent for 1 month. By keeping this value in a variable, we can refer to it easily whenever we need it. We can also change the value later, showing that variables act as flexible placeholders for data that may change over time. We represent the monthly grocery cost with a variable set to $350. This variable serves as a placeholder for grocery expenses in the program. Using a variable makes it easy to update or reuse this cost whenever needed in the code. This line of the program prints the current values stored in the variables along with clear labels. It shows the person's name, the monthly rent, and the grocery costs. By displaying these values, it lets you see exactly what information each variable holds at that moment in the program. The code changes the stored monthly grocery cost to a new value of $400, reflecting updated information. This shows that variables are not fixed and can be modified as needed. By assigning a new value, the example highlights how variables act as flexible placeholders for changing data. We set a variable to represent the monthly transportation cost as $150. This value serves as a placeholder for transportation expenses, so it can be easily updated or used in later calculations or reports. Assigning the specific amount makes the code clearer because it shows the purpose of the value and the current state of this expense category. It also helps keep the code more organized and easier to maintain over time. This example shows how variables act as flexible placeholders for changing information. The program updates the grocery cost, then prints that new value along with the transportation cost. By displaying these updated amounts, it demonstrates that variables can store and show current, dynamic data rather than fixed numbers. This script shows how variables in a program can store and update information over time. It begins by assigning values to represent a person's name, monthly rent, and grocery costs, then prints them to show how each value is labeled. The script then changes the grocery cost to reflect a new amount, demonstrating that variable values are flexible. It also adds a new value for transportation cost and prints everything again, highlighting how variables can be modified and expanded to hold new data as a program runs. Assigning values to variables. Assigning a value to a variable means telling the computer to store a specific piece of information under a chosen name so it can be used later. You can think of the name as a label and the stored information as the value. For example, in a program that tracks study time, you might create a variable for the hours studied today and give it the actual number of hours. Whenever the program uses that name, it retrieves the stored value for calculations or messages. This basic process is essential for handling changing information in programs. Assigning a value to a variable means giving a name to a specific piece of data at that moment, such as a number, text, or a more complex structure. For example, in a budgeting tool, you might use variables to represent your rent, bank balance, and savings goal. As your financial situation changes, you update these variables so they hold the new values. The computer keeps track of these name-to-data links, so you can build logic around them without needing the computer to understand their real-world meaning. Assigning a value to a variable is not a one-time action. You can change it as the program runs, so it always holds the most current information. For example, a step counter might start at 0 and be updated as you walk, or a program might adjust a temperature reading or game score over time. Each new assignment replaces the previous value, so the variable always reflects the latest state. Understanding this dynamic behavior is key to writing programs that respond to changes and user interactions effectively. Python code: assigning values to variables. This script introduces how to assign values to simple, descriptive variables in a program. It shows that variable values can change over time as the program runs. By printing the values, you can clearly see how each assignment updates what the variable stores. Overall, it helps you understand how variable assignment and updating work in practice. This line is simply a placeholder comment reminding developers that they may need to install external libraries before running the script. It serves as a general note about possible dependencies. In this particular code, no external libraries are actually required, but including such comments is a common practice to help ensure all needed packages are installed in other cases. We begin by creating a variable that represents how many hours were studied today, and give it an initial value of 2. This starting value records the first amount of study time for the day. Using a clear, descriptive name for the variable makes the code easier to read and understand. It also prepares us to track and update the total study time as the day goes on. The code starts by setting the daily steps variable to 0, meaning no steps have been recorded yet. This initial value serves as the starting point for the day. As steps are taken, this value can then be updated and used for tracking and calculations. We start by giving the daily water intake variable an initial value of 16 ounces. This number serves as the baseline for how much water has been consumed so far. From this starting point, we can update the value and track changes in water intake throughout the day. The code first prints the starting values for 3 variables that track study hours, steps, and water intake. It labels this output as the morning values, so you can clearly see the initial state of each variable at the beginning of the day. This creates a baseline that you can later compare with updated values to observe any changes over time. The program changes the recorded study time to 4 hours, reflecting additional study after an afternoon session. This update shows how the code keeps track of changing information as activities continue through the day. It demonstrates that the program can modify stored data to stay accurate over time. The code updates the value that tracks today's steps to 3,500. This new value reflects the steps counted after a short neighborhood walk. It shows how the stored number changes to represent new data collected during the day. In other words, the variable is adjusted, so it always matches the most recent step count. The program updates the recorded water intake to a new total of 32 ounces after another glass is consumed. This shows how the code keeps track of water consumption over time. Each time more water is drunk, the total amount stored by the program is adjusted to reflect the new overall intake. The program prints the updated values of the variables to show their new assignments after changes are made. It reports the current study hours, steps taken, and water intake for the afternoon. This output provides a quick snapshot of your progress at that point in the day and helps you see how these values have evolved. The code changes the recorded study time to 5 hours, indicating that an additional evening study session has been added. This shows how the program updates the total study time as more sessions occur throughout the day. The program updates the value representing today's steps to 8,000 to include an additional evening walk. This change adjusts the total steps for the day so it reflects all recorded activity. By keeping this value current, the program can accurately track and monitor daily step counts. The program updates the water intake value to a new total of 48 ounces, reflecting additional water that has been consumed. This change helps track ongoing daily hydration. The updated amount is then used to represent the current state of water intake as the program continues to run. The program displays the final values for study hours, steps, and water intake at the end of the day. These values reflect all the updates made as the day progressed. The output serves as a brief summary of the day's activities, showing how each value changed from its starting point to its final state by evening. This script shows how variables can change over time to model daily activities. It starts by setting values for study hours, steps taken, and water intake in the morning. As the day moves into the afternoon, and then evening, these values are updated to reflect more studying, walking, and drinking water. At each stage, the current values are printed, demonstrating how variables can dynamically track real-world changes throughout the day. Variable naming basics. When you name storage locations in your code, choose clear, descriptive names that show what kind of information they hold. For example, a name that includes the word age is better for storing a person's age, and a name with price or cost is better for a product's price. This may feel like extra effort at first, but as your programs grow, these meaningful names make your code much easier to understand and maintain over time. Choosing good names in programming means making them both descriptive and consistent. Use a clear, readable style, such as joining words with underscores and keeping them lowercase, so terms like monthly rent or student count are easy to understand. Avoid names that are either too long or too cryptic, because they become hard to use or remember. The goal is to strike a balance where names are informative but still practical. And with practice, you will naturally develop a sense for this balance, much like how you label things in everyday life. Choose variable names that clearly match what the data represents, and avoid names that suggest a single item when the value is actually a collection. Do not reuse similar names for different purposes, because this can create subtle, hard-to-find bugs. Instead, think about how your future self or a colleague will read the code, and make sure each name's purpose is obvious without extra explanation. Clear, accurate names make programs easier to read, debug, and extend in any domain, whether you are working with financial data, health metrics, or research results. Python code, variable naming basics. This lesson focuses on using clear, descriptive variable names in simple Python programs. You will see how confusing names compare with readable names when they store the same information, and how this affects code understanding. The printed output will make it obvious which naming choices are easier for beginners to follow. Overall, the goal is to highlight that good variable names make code more readable and learning Python less confusing. This line serves as a reminder to install any libraries the script depends on before running the code. It highlights the need to make sure all required packages are available so the program can work correctly. In Python, This is typically handled with a package manager such as pip, which is used to manage and install these dependencies. This example describes code that defines 3 variables with unclear, generic names and assigns them the values 72, 3, and 216. Because the names do not explain what these numbers represent or how they are related, the code is hard to understand. The point of the example is to show how poor naming practices can confuse readers. It emphasizes the importance of using descriptive variable names that clearly communicate each value's meaning and role in the program. We define 3 basic values for our example. The monthly rent is set to $1,200. The apartment area is 600 square feet, and the number of roommates is 2. Each value is given a clear, descriptive name, so it is obvious what the number represents. Using meaningful names like this makes it easier to understand and use these values in later calculations about sharing rent and space. To find how much rent each roommate pays, take the total monthly rent in dollars and divide it by the number of roommates. The result is the rent per person. Using clear descriptive names for these values helps make the calculation easy to read and understand. This code prints a message to the console that demonstrates the problem of confusing variable names. It shows a short label followed by the values of 3 numeric variables whose names do not describe what the numbers mean. Because the names are unclear, the data they hold is hard to interpret. The example is used to highlight how poor naming choices can hide the real meaning of the information in a program. This line displays a message that clearly labels the monthly rent amount in dollars. By choosing a descriptive name for the value it prints, the output is easy to understand at a glance. This highlights how clear naming helps make program results more readable and meaningful. This line of code prints the apartment's area in square feet using a clear, descriptive name for the stored value. By directly tying the printed number to its meaning, it makes the output easier to understand. Using meaningful names instead of vague or confusing ones improves both readability and long-term maintainability of the code. This line displays the rent each roommate must pay, along with a clear label, so the output is easy to understand. It shows the result of dividing the total monthly rent by the number of roommates. The example highlights how using descriptive names makes the calculation and its purpose more readable. This material explains why clear, descriptive variable names are important when writing Python programs. It contrasts confusing names that hide a variable's purpose with meaningful names that show what the data represents, such as monthly rent, apartment size, and number of roommates. The script then uses these descriptive names to calculate rent per roommate, making the calculation easy to follow. By comparing the outputs from confusing and clear names, the example shows how good naming conventions make code more readable and especially helpful for beginners. Reading user input. Getting user input. When a program interacts with a user at the keyboard, it must pause, request input, and wait for the user to type a response. The program then captures this response and stores it, so it can be used in later steps. This creates a simple conversation where the program asks, the user answers, and the program remembers the answer. By doing this, the program can change its behavior based on what the user enters, such as a name, a menu choice, or a number for a calculation. When a program receives input from a user, it stores that information in a variable with a meaningful name so it can be used later. This storage step is essential because it lets the program check conditions, perform calculations, and make decisions based on what the user entered. By keeping user input in variables, the program can trigger different actions and respond in a way that adapts to each user's choices, making the interaction dynamic and responsive. User input is essential in everyday software because programs need information from you before they can respond correctly. When you book a flight, the system uses your chosen cities and dates to search for options. When you log into a university portal, it uses your username and password to verify your identity. Even a simple study tool must know how many practice questions you want before it can generate them. In all these cases, the program pauses to collect your input, stores it, and then adjusts its behavior based on what you provide. Python code, getting user input. In this activity, you will practice getting input from the user, saving that input in clearly named variables, and then using those saved values to produce output. You will ask the user for information, store each response in a separate variable with a meaningful name, and then print a short message that includes those stored values. This helps you understand how to collect data from a user and reuse it in your program's output. This line is simply a placeholder indicating where you would install any libraries needed for the script to run. It serves as a reminder to check that all required dependencies are installed before executing the code. In a real project, you would replace this placeholder with the actual command to install a specific library using the standard package manager, if it is needed. The code tries to collect 3 pieces of user input: the person's first name, their favorite city, and how many miles they can walk comfortably. These prompts are placed inside a try block so the program can handle any errors that occur while reading input. If something goes wrong, control moves to the accept block, where the program assigns default values instead. In that case, the first name becomes test user, the favorite city becomes test city, and the walking distance is set to 5, allowing the program to keep running even when user input fails. The code prints a blank line to improve how the console output looks. This extra space separates different sections of the output. As a result, the information is easier to read and appears more organized and visually clear. This code creates a personalized message by combining the user's first name with their favorite city. It starts with a friendly greeting that says hello to the user by name. Then, it adds a short sentence that states the city the user likes. The result is a simple, engaging output tailored to the information the user entered. The program prints a personalized message that includes the walking distance the user entered. It uses a print function to combine a fixed sentence with the stored distance value. The result is a short, encouraging statement that tells the user their ability to walk that many miles is impressive. This script asks the user for their first name, favorite city, and how many miles they can comfortably walk. And if any of these inputs fail, it switches to preset test values. After gathering the information, it prints a friendly message that greets the user by name and mentions their favorite city. It also comments positively on the distance they can walk, treating it as an impressive ability. Throughout, the code uses exception handling, so it continues running smoothly even when input errors occur. Text input basics. When handling user input, start by treating everything as plain text, even if it looks like a number. This makes it easy to store responses for later use, such as personalizing messages or analyzing data. Accepting input as text also lets you handle a wide range of answers, including names with spaces or emails with special characters. Once the response is stored as text, you can then decide if it needs to be converted into a specific format, like a number or a date. When working with text input, remember that users type in many different ways, with extra spaces, different capitalization, abbreviations, and mixed symbols or languages. Your program records exactly what they type, so to compare their input with predefined options, you often need to standardize it, for example, by trimming spaces or adjusting capitalization. The same idea applies to things like phone numbers, which may include formatting characters that you can choose to keep, remove, or transform. Handling these variations carefully makes your program more flexible and user-friendly. How you phrase user input prompts strongly affects the quality of the responses. Vague instructions can lead to unclear or incorrect answers, while specific wording, such as asking for a full legal name, produces more accurate input. In forms and surveys, clear prompts reduce errors and confusion and make later processing and display easier. With experience, you learn to anticipate misunderstandings and refine your wording to consistently guide users toward the information you need. Python code. Text input basics. This section focuses on basic text input handling by using simple prompts to collect user responses. It explains that the values entered by the user are stored and treated as plain text. It also shows how to clean up this text by trimming extra spaces and adjusting capitalization, so the final input looks neat and consistent. The commented line is a reminder to install any external library the script depends on. It serves as a placeholder for whatever package is required for the code to run correctly. Before running the script, you should make sure all such dependencies are installed, usually with a package manager like pip. Doing this helps prevent runtime errors caused by missing libraries and keeps the script functioning as intended. The program starts by asking the user to enter their full name. Whatever the user types is treated as text and saved for later use. This step lets the program interact with the user and collect personalized information that can be processed in subsequent parts of the code. The program asks the user to type in their favorite city as plain text. If something goes wrong during this input step, such as an unexpected error, the program does not stop. Instead, it assigns a default value of sample city to the city information. This approach keeps the program running smoothly, even when user input fails. This code cleans up the user's input by removing any extra spaces. It takes the raw name and uses a trimming method to cut off spaces at the beginning and end, then stores the cleaned result. It does the same for the city input, creating a cleaned version without leading or trailing spaces. This process ensures the stored text is neat, consistent, and free of accidental extra spaces. To standardize the city name, we apply a title-style capitalization method to the cleaned city text. This method capitalizes the first letter of each word, putting the city name into conventional title case. Doing this makes the text look more polished and consistent, especially when the original user input was all lowercase or all uppercase. This line displays exactly what the user typed for their name. It uses a function that shows the raw input, so any special characters or extra spaces are clearly visible. This provides an accurate, unmodified view of the original text the user entered. This line displays a message in the console that shows the cleaned version of the user's name. It uses a print command to say that after trimming spaces, the name becomes a new, tidier form. The stored value contains the user's name with any extra spaces at the beginning or end removed. This helps present a neat and standardized version of the input. This line displays a message to the user that includes the cleaned and capitalized city name. It uses the stored city name with the first letter of each word converted to uppercase. This ensures the city is shown in a neat, consistent, and easy-to-read format. The code creates a single, friendly sentence by combining the cleaned version of the user's name with the capitalized version of their favorite city. It inserts these values into a simple sentence structure to clearly state who the user is and which city they like. This produces a personalized, easy-to-read summary of the user's input, improving how the result is presented. This script shows how to handle simple text input in Python by asking the user for their full name and favorite city, then storing these responses as plain text. If something goes wrong during input, it falls back to default values. The program removes extra spaces, standardizes the capitalization of the city name, and then displays the original input along with the cleaned name and formatted city. It finishes by printing a short summary sentence saying that the user loves the chosen city, illustrating basic text trimming and capitalization techniques. Subtitle. Once you can ask users questions and record their answers, the next step is to understand what those answers mean and how your program will use them. Inputs like a name, age, or quantity are not just random text. They are meaningful data that should be handled with a clear purpose. For example, in a survey, you might store a participant's city, favorite music genre, and listening hours in clearly labeled places so you can easily use them later. Thinking this way turns user interaction into a structured conversation, where each response has a specific role in your application. When designing user interactions, you must plan for unpredictable human input, such as unexpected values, empty fields, or misunderstood prompts. These issues can cause errors in applications like registration forms or booking tools. To make your system more robust, provide clear prompts, validate what users enter, and handle mismatches in a calm, helpful way. Adding checks and follow-up questions improves data accuracy and helps keep the information you collect reliable. This leads to applications that are both more dependable and more user-friendly. As you improve how you collect and store user responses, it will shape the design of your programs. A budgeting tool, for example, can ask for income and expenses and use that data to give personalized feedback, while a quiz app can track answers, scores, and a player's name to create a custom final message. The key idea is to treat user input as structured data that moves through your program. This makes your applications more interactive, reliable, and personalized as your skills develop. Python code. Subtitle. Capture user input and turn it into meaningful values. Then store each response in clearly named variables so you know what each value represents. After collecting the inputs, reuse these stored values to generate and display a brief summary of the user's answers. This approach keeps the data organized and makes it easy to present a clear overview of the information gathered. This line is simply a placeholder comment reminding you that you may need to install a required library before running the script. It emphasizes checking that all necessary external packages are installed so the code can execute correctly. Including such reminders is a common practice when sharing code that depends on additional libraries. The code starts by asking the user to type the name of the city where they live. It does this with a user input prompt that displays a message and waits for a response. Whatever the user types is then saved in a variable so the program can remember it. This stored city name can be used later in the program whenever that information is needed. The program asks the user to enter their favorite music genre and uses an input command to capture what they type. It then saves this response in a variable, so the answer is stored in the program. This stored information can be easily used later for other actions or outputs. The program asks the user how many hours per week they listen to music and stores this response. If something goes wrong during this input step, such as an unexpected error, the program does not stop. Instead, it assigns default values, setting the city name to unknown city, the favorite genre to unknown genre, and the listening hours to 0. This use of fallback values allows the program to keep running smoothly, even when user input fails. The code prints a blank line to improve how the output looks in the console. This extra space visually separates different parts of the program's results. As a result, the output becomes easier to read. It also helps the user quickly distinguish between sections of information. This line creates a friendly summary sentence using the city name and favorite music genre the user provided. It combines these stored responses into a personalized message. The program then prints this message to the console, giving the user immediate feedback about the information they shared. This line of the program prints a message to the console that tells the user how many hours they listen to music each week. It uses a value that was previously collected from the user and stored earlier in the script. By doing this, the program shows how it can take earlier input and turn it into personalized feedback for the user. The code prints a message to show that each user input is stored in a separate variable. This demonstrates how organizing data into distinct storage locations keeps it clear and easy to work with. By keeping inputs separate, the program can access and manipulate each piece of information more effectively later on. This script asks the user for their city, favorite music genre, and how many hours they listen each week. then stores each answer in its own variable. If any input fails, it uses default values instead. After collecting the information, it prints a short summary that combines the city and music preference, followed by a statement about weekly listening time. Overall, it demonstrates a simple way to gather user input, handle possible errors, and produce clear output in Python. Printing variables. Printing variable values. When you begin programming, an essential skill is understanding what your code is doing, and printing values is a key way to do this. By printing information such as a name, an age, or the result of a calculation, you can check that the program is storing and updating data as you expect. This is like having the computer tell you what it currently knows, so you can confirm your logic is correct. Using printed output in this way helps you communicate with users and, just as importantly, understand your program's behavior step by step. When you print a variable, the computer turns its internal value into text you can read on the screen. This might be a word, a number, or a more complex result. But the goal is always to make the program's state visible. For example, showing the subtotal, tax, and total in a meal cost script, or displaying a student's name with their average score in a grade calculator, helps users follow each step. In this way, printing values provides clear feedback that makes the program's results easy to understand. Printing variables is not just for quick checks. It is a way to clearly present your program's results. By choosing which values to show and arranging them carefully, such as key fitness or budgeting information, you turn raw data into a clear message. This thoughtful output helps users understand what the program is doing, improves transparency, and builds trust in the results. Python code, printing variable values. This lesson focuses on how to store values in simple variables and see what they contain. By assigning information to a variable, you can keep track of data such as numbers or words. When you print a variable, the program shows you the value currently stored in it. This printed output can then be connected to meaningful everyday information, helping you understand what the stored values represent in a real context. We create variables to store different types of information so we can use them easily in a program. For example, we store a person's name as Alex Johnson, the current outside temperature in Fahrenheit as 72, and the number of items in a shopping cart as 3. Each variable holds a specific piece of data that can later be used for comparisons, calculations, or tracking quantities in the code. We first display the stored name so we can confirm which name is currently saved. Then we display the stored temperature value to verify that it matches the correct temperature in Fahrenheit. Finally, we display the stored count of items in the shopping cart to confirm how many items are currently being tracked. Printing these values helps us quickly check that our data is accurate. We update the temperature value to 80 to represent a warmer afternoon, such as when the sun comes out. After making this change, we display the temperature so we can confirm that the new value has been applied correctly. Seeing the printed value of 80 verifies that the update to the temperature was successful. This description explains a simple Python script that shows how to store and display values using variables. It assigns a person's name, a temperature in Fahrenheit, and a number of items in a shopping cart to separate variables, then prints these values. The script then changes the temperature to a warmer value and prints it again. Overall, it demonstrates that variables can be updated and that printing them shows their current values, illustrating basic variable manipulation and output in Python. Using f-strings. Formatted strings, often called f-strings, are a clear way to display messages that include variable values. They let you write sentences in a natural way and insert data directly where it belongs. When the message is shown, the placeholders are replaced with the actual values. This makes outputs like greetings or summaries smooth, readable, and easier to understand in your code. F-strings are especially helpful when you need to build complex messages that combine several pieces of information in one clear sentence. For example, in a program that tracks a student's progress, you can easily include their name, grade, and completed assignments in a single message. The same idea applies to summarizing a shopping cart or reporting weather conditions. By using f-strings, you focus on what the message should say instead of manually joining text fragments, which keeps your code cleaner and your output easier to understand. F-strings make your programs more flexible and easier to update as requirements change. They let you quickly adjust wording, add or remove values, or change the order of information without messy string concatenation. This is especially helpful in interactive tools like quizzes, budgeting apps, or fitness trackers, where clear, personalized feedback matters. By using f-strings, your messages stay readable, adaptable, and more professional for users. Python code using f-strings. This section focuses on using f-strings to create clear, readable printed messages. It explains how you can place variables directly inside formatted sentences with f-strings, so the output is easy to understand. It also compares this approach with plain string concatenation to help beginners see why f-strings are often simpler and more readable. Overall, the goal is to show how f-strings make it easier to build informative messages that include variable values. This line is simply a placeholder comment indicating where you could add a command to install any extra libraries the script might need. It serves as a reminder to check that all required dependencies are installed before running the code. In this particular script, however, no external libraries are actually necessary. We define a variable to store the product being purchased, in this case, a notebook. Another variable holds the price of one notebook, which is 4.5, and a third variable stores the quantity, which is 3. Together, these values describe a simple online purchase and provide the information needed to calculate the total cost and create descriptive messages later in the program. To find the total cost of an online purchase, multiply the price of one item by the number of items you are buying. This calculation gives you the full amount you need to pay. In other words, total cost equals the cost per item times the quantity purchased. This line prints a message by joining several pieces of text together, such as the number of items, the item name, and the total cost. Any non-text values, like the quantity and cost, are first converted to strings so they can be combined with the rest of the message. While this works, it often makes the code look cluttered and harder to read compared with using formatted string literals, which express the same idea more clearly. An f-string lets you insert variable values directly into a message, making the output more readable and concise than traditional string concatenation. In this example, it embeds the quantity of items, the item name, and the total cost right inside the sentence. This produces a clear, straightforward message that states how many items were bought, what they are, and the total price paid. We define a starting city called Denver and an ending city called Boulder to represent the beginning and end of a road trip. We also specify the distance between these two cities as 30 miles. Together, these values set up the basic information needed to describe this short trip. This line uses a formatted string to build a clear sentence describing a road trip. It automatically places the values for the starting city, ending city, and distance in miles directly into the sentence. This makes the message concise, readable, and easy to understand without needing extra steps like string concatenation or manual conversion of values. This script shows how Python f-strings make printed messages clearer and easier to read. It uses a simple online purchase of 3 notebooks and a short road trip from Denver to Boulder as examples. The total cost of the notebooks is calculated and printed first with basic string concatenation and then with f-strings, so you can compare the two styles. The road trip example also uses an f-string to smoothly insert distance and location details into a sentence. Overall, the script demonstrates that f-strings simplify embedding variable values in text and help keep code concise and readable. Simple interactive script. Imagine a simple assistant program that greets users by name and asks about their interests, such as a favorite hobby. It stores each piece of information separately, like the name and hobby, then combines these stored values into a sentence template. The result is a friendly, personalized message that feels tailored to the user. Even though it is just using stored data and a fixed structure, this method makes the interaction seem more human and less mechanical. A program can turn simple user inputs into a natural-sounding summary. For example, it might ask when you wake up, how long you plan to work or study, and how you prefer to relax. Then combine these answers into one smooth sentence describing your day. This same approach can be used for budgeting by restating your income and expenses, or for travel planning by confirming your destination and travel details in a clear message. The key idea is to store basic responses and then echo them back as a coherent narrative. When designing interactive experiences, focus on a clear conversation flow that guides the user from start to finish. Begin with a simple greeting, then ask for the key details you need, and end with a brief summary that restates the information in plain language. For instance, a study planner might collect the course name, weekly study hours, and main goal, then respond with an encouraging recap. Practicing this structure helps you plan how programs communicate, which is essential for building more complex applications. Python code. Simple interactive script. This activity shows how to build a simple interactive script that talks with the user. It asks the user for basic details, then stores each answer in a clearly named variable. After collecting the information, the script combines these stored values into one friendly summary message. The goal is to practice using input to gather data, print to display results, and descriptive variables to keep the information organized. The commented line is a placeholder reminding you where to add a command to install an external library if it is needed. It indicates that you might use Python's package installer to add any required dependencies. This helps ensure that all necessary libraries are available so the script can run correctly. The code starts by using a try block to collect several pieces of information from the user. It asks for the user's first name, then asks what time they usually wake up, and finally asks how many hours they plan to study or work. Each answer is stored so the program can use these personal schedule details later. The program asks the user what they like to do to relax in the evening and saves that answer. If something goes wrong while getting this input, it falls back to safe default settings. In that case, it uses a generic username, sets the wake-up time to 7 o'clock, the work duration to 8 hours, and the relaxing activity to reading. These defaults allow the program to keep running smoothly even when user input fails. The code first prints a blank line to separate the output and make it easier to read. It then builds a friendly summary message using the stored user details. The program greets the user by name, mentions their planned wake-up time and work hours, and adds their preferred relaxing activity. Altogether, it creates a brief, personalized summary that makes the interaction feel engaging and positive. This script is a simple interactive console program that asks the user for basic personal details, such as their name, when they wake up, how many hours they plan to work, and what they like to do in the evening. It then uses these answers to create a friendly summary of the user's day. If any input step fails, the program falls back to default values so it can still run. Overall, it demonstrates basic user input handling and string formatting in Python in a straightforward way. In this lecture, you learn to create and assign variables using clear and descriptive names. Use the input function to read user input and store it in variables. And combine variables and print to display formatted messages to the user. In the next module, Module 3, we will go over control flow.
Thank you for your attention. See you all in the next lecture.